What happens? Remember, we have first four phase. Pyruvate is converted to what? Acetic in the presence of oxygen. We have treated that. Now, pyruvate is now converted to lactate in the absence of oxygen. Remember that. There are four things that will happen to pyruvate after glycolysis. To what? Acetyl-CoA in the presence of oxygen is converted to what? Lactate dehydrogenase in the absence of oxygen is converted to alanine if our body needs non-essential amino acid, and it is converted to oxaloacetate if our body demands for oxaloacetate. So pyruvate and lactate, it is a reversible process, but converting pyruvate to acetyl-CoA is an irreversible process. So when you convert pyruvate to acetyl-CoA, your body cannot reverse that process. The only thing your body can do is to reverse the conversion of pyruvate to lactate. They are reversible. Now, during this process, I look at the structure of our pyruvate. It is now then converted to what? Lactate by an enzyme known as what? Lactate dehydrogenase. And anytime you heard of lactate dehydrogenase, we are taking NAD positive and we are converting them to what? NADH, or we are taking NADH and we are converting them to NAD positive. Now, what is lactate dehydrogenase enzyme doing? Lactate dehydrogenase enzyme, its works or its function is to convert pyruvate to lactate in the absence of what? Oxygen. But immediately there is oxygen in the body, it will start converting this lactate back to pyruvate. Why? Your body is going to make ATP. So your body cannot make ATP from lactate. Your body has to convert it first to pyruvate before it's now acted by pyruvate dehydrogenase to convert them to acetyl-CoA, which will now enter the Krebs cycle in the electron in the mitochondria in the electron transport chain to produce what? Energy. And during the process by which pyruvate is converted to lactate, NADH is converted to what? NAD positive. The process, note that the process by which pyruvate is converted to lactate, NADH and hydrogen ion is converted to what? NAD positive. Why? This NAD positive, we continue taking hydrogen and electron to proceed glycolysis and to be producing little amounts of energy before you now rest. When you now rest, the main energy will now start producing. So that is why during the process by which you convert pyruvate to lactate, your body do something by converting NADH to NAD positive, which we keep on this NAD positive will keep on stimulating the formation of pyruvate, and as we keep on forming pyruvate, this pyruvate keep on converted to lactate and is producing low amount of energy, which means it's taking ATP molecule, it's taking ADP molecule and is converting them to what? ATP molecule in the absence of oxygen. Remember that. So the equation for you is pyruvate reacts with NADH plus hydrogen ion in the absence of oxygen. Don't forget that in anaerobic process, absence of oxygen, to convert them to what? Lactate and NAD positive. This NAD positive will stimulate the formation of what? Pyruvate in the process called glycolysis. Conversion of glucose to pyruvate is called glycolysis. So NAD positive stimulates the formation of what? Glycolysis. Whenever NAD positive is high, it stimulates the formation of what? Pyruvate in the process known as what? Glycolysis. And where is all this reaction taking place? In the cytosol of the membrane of the mitochondria. So we have physiological purpose. This reaction regenerates the NAD positive required for the glyceraldehyde 3-phosphate dehydrogenase step of glycolysis. So remember, there is an enzyme called glyceraldehyde 3-phosphate dehydrogenase. So what is this enzyme doing? This enzyme keep on converting glyceraldehyde 3-phosphate to another substrate, so that NAD positive will now convert it to NADH, and we now proceed and we now form another substrate that will now form the pyruvate, that will keep on processing the formation of what? Pyruvate. So NAD positive serve as another pathway in glycolysis by what? By accepting hydrogen and electrons, stimulating the formation of what? Pyruvate in the process known as what? Glycolysis. This allows for continued ATP production under anaerobic conditions. So when this NAD positive arc is continuously producing NADH, and this will now yield to more of glycolysis, more of breaking down of glucose to pyruvate, this will now lead to an anaerobic process. When there is no oxygen, more of this pyruvate is keep on converted to what? To lactate, and this will now release ATP molecule, 2 molecules of what? ATP, and these 2 molecules of ATP will sustain you so you start resting. During the resting phase, that time you have started breathing well, there is availability of oxygen. This lactate is now converted back to pyruvate, and this pyruvate will now release what? NADH, that will go into the electron transport chain to produce energy, and pyruvate is now converted to acetyl-CoA that will go into the Krebs cycle, produce NADH and FADH that will go into the mitochondria to produce energy. I will show you how this NADH produce energy in the electron transport chain. Just have it in mind that we are continuously producing NADH because we need them in the mitochondria, in the electron transport chain. They are the main people functioning in the production of energy.